Welcome to Future Talk. On today's program, we're going to talk about artificial intelligence. What exactly is it? What can it accomplish? And what are some of the most promising areas of development? My guest is one of the world's leading experts on AI. He is Peter Norvig, and he's the Director of Research at Google. He's also a fellow of the Association for the Advancement of Artificial Intelligence. He's co-author of the leading college textbook in AI, and he was the co-creator of a popular online course in AI that had over 160,000 students enrolled. Before joining Google, Peter worked at the NASA Ames Research Center, where he was head of the Computational Sciences Division, worked on robotics and neuroengineering, supervised a staff of 200 scientists, and won the NASA Exceptional Achievement Medal. He has a PhD in computer science from the University of California, Berkeley, and is the recipient of a Lifetime Achievement Award in Innovation from Berkeley Engineering. Peter, welcome to the program.
It's great to be here. Thanks for having me.
Now, I've heard that Google has a very casual atmosphere. Is there any truth to that rumor?
Well, you can see I'm all dressed up today.
You look like you just came from the beach.
We're just trying to get the job done.
Well, that's good. This is California. You know, dressing and performing go hand in hand. So it's great to have you on the show. You're an expert in the field. I'm looking forward to learning more about artificial intelligence. Now, what exactly is artificial intelligence? What are we talking about? Are we talking about a simulation of human intelligence?
Well, there's been a lot of different approaches, and there's two factors to think about. So some people say artificial intelligence is about simulating human intelligence, and others say it's just doing the best job you possibly can. And then the question is, how do you evaluate whether you're doing the best? And then again, there's a split. Some people say, well, let's say, is the reasoning process correct? Are you saying if A, then B, and are all those steps logically correct? And others say, that doesn't really matter. What really matters is do you get the right answer in the end? And I think the more modern approach is to take that, to say, what AI really is building programs that do the right thing, and do that when you don't know what the right thing is.
Well, what are some of the achievements of AI? What has it accomplished so far?
So AI is everywhere. It touches you every day of your life. It's routing your phone calls and your internet traffic so that that's done optimally. It's approving your credit card transactions to detect fraud. It's filtering out the spam from your email. And so it's become a pervasive part of society today. Recently, there's been a bunch of kind of high-profile applications of AI. For example, the driverless cars have been quite popular. The IBM Watson program that won on Jeopardy. The Siri and other voice recognition programs that allows you to talk to your phone or your computers.
Well, that driverless car is very interesting, and I know that Google has been working on it, and I know you can't say that much about it, but just briefly, what are some of the problems that have to be solved in order for the driverless car to work?
We got to be able to perceive the environment, understand what's going on, and react very quickly. And so part of that is kind of a mapping application. And so it seemed to make sense for Google to be involved, because we've already done a lot of work with maps. We have high detailed descriptions of where all the roads are, where all the pictures of the roads and so on. And we can go from that and understand where we are and navigate on a road. And so
it has to be able to read street signs, has to know the road laws, traffic laws.
It's got to know all of that as well. And then, so part of it is, if nobody was on the streets, can you follow the roads accurately and not get lost? So that's the easy part. Then the hard part is, well, you're not the only one on the street, that there's other cars, there's pedestrians, and so on. And so you've got to be able to recognize those as well. And so that we use a combination of different sensors to do that. So we have several different cameras, and we have range finding with radar and laser rangefinder, so we can detect how far away an object is. And then we track that over time and form a model of what's what and what they're going to do. We have to be able to follow all the laws, of course. It turns out you got to go a little bit beyond the laws as well. When we first programmed the cars, you look in the driver's handbook and you say, what happens when you get to a four-way intersection and who has to yield and so on, and we faithfully put that into the cars. And then we found out if there's a lot of traffic, you never get to go. And so we had to say, well, you don't really quite follow the rules. Instead, you kind of inch out a little bit to signal that you want to go next. And
so it's basically experience. You basically learn.
There's a lot of learning involved. When we start out, we don't just send the car out on its own. We send a human driver on the road first and have them drive and follow all those actions with the GPS, get a very accurate map of how a human would drive this road. And then we tell the car, do it like that.
Okay, so a person has to drive the same road first to sort of program the car. And does the car give control over to the human? I mean, are there situations where the car says, I don't know what to do, I need this guy in the passenger seat to take control?
That's right. So right now, remember, it's all prototype, experimental. It's not a product yet. And so now we've actually got two guys in the front seat, one behind the steering wheel who most of the time is doing nothing, and then one sitting next to them who has a monitor that's displaying sort of all the functions of the car and just sort of keeping track of what's going on. And there is a way for the car to cede control, say I'm confused, and there's a way for the guy in the driver's seat to press the red button and say I'm taking over.
Is there an expectation that, in the lifetime of most of us today, we'll have cars that can drive without human intervention? Because the whole point of being in a driverless car is that you can read the newspaper or take a nap or watch TV and not have to watch the road.
That's right. So I think that will happen. I think it will happen gradually in stages that will, and we're already seeing cars becoming more capable, right? So, the first applications were cruise control and then ABS braking systems, which are computer controlled, but a very limited form. And you're starting to see more and more of that. Now we have cruise control that's aware of the car in front of you and will slow down. So that's a little bit more autonomy on the part of the car. It's not steering itself, but it's keeping its speed. And I think you'll see more and more. Now the big question is, when can the driver go to sleep? And we aren't quite ready to hit that phase yet. And we'll have to be very careful about how to phase that in and how to set the expectations for the drivers of how alert they have to be, how ready do they have to be to take control back.
And it's not really going to be very useful if the driver has to be ready to take control back all the time. So to be a commercially successful product, it really has to be autonomous, I think.
Right, it's got to have autonomy. And there's a couple different use cases. One is when you're commuting, can you be reading or sleeping or whatever? Another use case is when you're out of the car. So, instead of searching for a parking spot, pull up in front of a building, you hop out, and the car acts as a valet for itself.
Now, what about robotics? You did a lot of work in robotics when you were at NASA. We usually think of a robot as a humanoid thing with arms and legs and a head that can sort of speak a little bit, and maybe he performs household tasks or does other useful stuff. Is that something that's becoming commercially practicable?
So not quite yet. I think we're getting there. So there are a few home robots you can buy. There's certainly a lot of robots in use in heavy industry. But for home robots, well, you can get one that will vacuum your floor. And some people find that useful. Some think of it more as a toy. I think you'll see more of those types of things. I think the robots won't necessarily be humanoid shaped. That's mostly for the movies. Instead of having one general purpose robot that will do everything that a human does, you'll have special purpose ones like the vacuum cleaner and so on. And so they'll be shaped for the task at hand.
Now, another very interesting thing is voice recognition. The iPhone has the Siri software, which you talk to it and it answers you. How hard is it to do that? And I mean, can you write a program that learns as it goes along? So the version you have on your phone can learn new words and new meanings while you use it, or is it limited by what it's programmed to do the day it was created?
No, so it's certainly built on learning, and all the modern speech recognition programs are based almost entirely on learning. And then it's a question of at what level do you learn at? And there's a lot of different things to learn. So it's learning the language in general, English as a whole. Then it's learning your specific voice. Then it's learning the vocabulary that you may use that other people don't use. And then it's learning your meanings of when you say this word, what do you mean? And so the learning's going on at all those levels. And then we got to figure out what do people want to do when they're talking to their devices. How do they want to think about their devices and interact with them? Is the device a slave or a buddy, or are you giving it commands, or are you having a conversation? I think we haven't quite worked that out yet. We went from computers we started working with punch cards and feeding them in, and then we got to be more interactive, and then we added a mouse and had a whole new set of conventions for how we interact with computers.
Well, there's been tremendous progress, but I'm wondering, in the course of creating artificial intelligence, does that necessarily give you greater insight into how natural intelligence works? Like, how does a human make a decision? How does a human organize his thoughts? How does he retrieve information from the memory, which is the PC wants at that time?
That's a great question, and I think it goes in both directions. So artificial intelligence and computer science is both helping biology and psychology and is helped by it. And you take insights in one field and you feed it into the other one. I'm approaching it from the computer science point of view, so I just want to say I want to get my computers to do the right thing. In doing that, I need to understand what's going on in psychology and biology for two reasons. One is humans and other animals are the best examples we have of intelligent systems, and so understanding how they work is helpful. Gives me some inspirations to understand how the computers work. Now, the computer doesn't have to work exactly like a person. The computer is very different in terms of the amount of memory it has, the speed of its operations, and so on. But you get inspiration from understanding more about how people and other animals do tasks, like their vision system and so on. And then it feeds back the other way, in that if we say, oh, well, this works in the computer, this doesn't, can the biologist say, does that make sense? Does that help me understand better how the human models work?
What would you say is the toughest problem that needs to be solved in order to make artificial intelligence really useful?
I guess understanding how to interact with it. That I think we have very good applications and models in narrow domains. I mentioned some at the start of the show, things like detecting fraud and spam and so on. So our computers are very good at doing one task at a time. But people are in some ways the opposite of that. People are good at doing lots of different things. And the range of what they can do is broader, but their expertise is not quite as good, right? So if I ask you to multiply 2 100-digit numbers, it's going to take you a long time to come up with the right answer. A computer can do it in a flash. But if I ask you to look at a picture and say, where's the mountain, where's the people, where's the stream, you're going to be really good at that, and the computer's not going to be as good.
So it sounds like replicating vision is one of the most important things. Having a camera look at an object and interpreting what that object is.
I think that's right, and I think it's a useful task. It connects you to the world, so we have a broader connection than just typing at a keyboard. Now, if a computer can see, it can interact a lot more and be more natural. And it's also important in terms of learning, because we have been able to teach our computers a lot by having them read text. There's a lot of text on the internet, so you can get a lot out of that, make a lot of connections, and know that this word goes with this other word, and other words don't go together. But they're still just words, and you really would like your computer to interact with the world and understand what it's like to live in the world. You can't quite have that, but it seems like video is the closest thing.
Well, I think Google has worked on this problem a lot, trying to interpret words, basic search, and you're an expert on search, doesn't know what a word means, but it can tell how frequently it occurs. But the next level of search would be to have a better understanding of what the word means, so it can figure out the nuances of what the person is asking for.
That's right. So the first level is just they ask for this word, show me the pages that have that word on it. The next level is to say, well, what did that word really mean? And maybe there's a page that talks about something, but it uses slightly different words that are synonyms or related words. And so we're able to do that to figure out which of the related words count and which ones don't. And then the next level is saying, well, you asked me a string of words, and it's important what the relationships are between those words, and figuring out that out. And so we have to attack understanding language at all level and understanding the world at all level of what do these words actually refer to in the world.
Now, Google is also getting pretty good at language translators. So, for example, there's an app in which you specify what language you're inputting and what language you want to output, and it can be typed or it can be spoken. Now, do you have to have somebody who's an expert in all those languages in order to program that? Or do you not even have to know the language in order to do
You know,
that?
we're able to do some of it without anybody on the team knowing the language. So I think, I'm not exactly sure of the number now, but I think we're up to something like 64 different languages. And you can translate from any one of them to any other one, so that's over 4,000 translation pairs. And for some of those languages, we didn't have anybody who spoke the language. And what we do is we go out and find examples, and we have an algorithm that our computer can learn from examples. And so the examples are, here's a text in English, here's one in French, and we know this document corresponds to this document because, of where we found them on the web. Somebody said that these are translations for each other.
Or you could just feed in a dictionary, like if you want to get Urdu or something.
Yeah, so you can use sources like dictionary, but we do most of our work from translations that a human has done. And so now we know if somebody asked me exactly for this page, I could spit back this page. But they're not going to ask me for exactly that page. They're going to ask me for some subparts. And so we have to figure out, not only does this page correspond to this page, but this phrase here corresponds to this phrase. Now we have a dictionary, not just a dictionary of words, but a dictionary of phrases. And then the trick is to fit all those phrases together. And that's kind of like doing a jigsaw puzzle. You say this fits here, where does this other one fit? And now they all go together.
Yeah. So it sounds like the knowledge is always increasing. It's sort of like building blocks, putting blocks together. It's a little slow at first. Maybe it's a little bit awkward at first, but as time goes on, it gets better.
That's right.
Well, let me ask you a question about robotics. Because one of the advantages of robots is that robots can perform tasks in environments that humans can't do it. For example, in space or under the sea.
Yeah.
So what does it take, say, to build a robot that explores the bottom of the ocean autonomously? It's not like it's a puppet and there's the guy on the ship telling it exactly what to do. It just goes out and gathers information and returns when it's ready, and then you download whatever it got.
That's right. And, so I did my robotics work at NASA, and we have robots, say, on Mars precisely for that reason, because it is a hostile environment. And more so than that, because we don't have to bring them back. Because if you send humans, then you really want to bring them back. And that's very expensive, because then you have to bring all the fuel to be able to launch a rocket again. But a robot, you don't need to relaunch it back. You just land it and you're done.
They're expendable.
They're expendable. And mostly we've had a mixture of autonomous operation and teleoperated operation. So you want the robot to have some capability to do things on its own, mainly because you can't be in communication with it all the time. If it's on Mars, just the speed of light limits the communication, and the planet is rotating, so sometimes you can't send a signal there. So you want it to be able to do some things on its own, but it can check in once or twice a day and take commands. Under the sea, similar kind of thing. You don't have a speed of light constraint, but if you're always transmitting, you're going to run out of battery power, and sometimes you're too deep down and you can't transmit. So it's got to be able to operate on its own and then pop back up and maybe get some more instructions.
Are there any risks to artificial intelligence? Some people think that at the rate things are going, our computers may soon be smarter than we are, and maybe they won't accept instructions for us anymore. Is that just a strictly science fiction scenario, or is there an opportunity that we're going to lose control of this technology?
I think you have to think very carefully about all new technologies and what the future implications are. So lots of the technologies we develop are dangerous, right? So Atomic weapons are certainly dangerous, and as a society, we figured out pretty well how to deal with them. Even technologies like the car is dangerous. Lots of people get killed in car accidents, and there have been repercussions on our environment and the way our urban planning is done. We didn't really foresee all the implications of relying on cars for transportation would have on the way our cities are structured. And so you can always think ahead and try to do a better job of planning for technology. Now, personally, I'm not so worried about these science fiction scenarios. I think, our computers are tools, and we're in charge of these tools. If you think about, well, are the computers going to be smarter than us? Well, the computers already are much smarter than us in certain things. So doing arithmetic, we can't keep up with the computer.
They're faster.
Remembering a trillion different web pages, a computer is going to be better than that, than a human. But making sense of those pages, humans have the upper hand for now. And so I think we'll want to have a mix of saying, well, what are humans good for? And we'll keep doing that. And what are our tools good for? And we'll build better tools to do that part.
Let's talk a little bit about your work at Google. Now, you're the Director of Research. Now, this is the Director of Research, not a Director of Research.
So I'm now actually a Director of Research. For several years I was the, and now we've grown, and now we have several who are
But are you doing as
co-directors
much as
with
you
me.
did before, but the amount of work has
That's
increased?
right, the total amount has increased.
So what do you do as a Director of Research? Do you decide which products are going to get worked on, or do you supervise the actual working on them?
Right, so I have a team working on different products, so sort of a portfolio of and a range of shorter and longer term. Everything we do at research is focused towards a product, and some companies have said, well, research should be kept separate from product because you don't want it to get it tied down. You want to have some long-term thinking. I think the way we think is we're not smart enough to think decades ahead into the future, so we're always going to be thinking about the product, and some of the research stuff is going to be longer range, and we've been able to do some exciting stuff with the cars and the glasses and so on, but we're always thinking about it in the context of a product, of saying what can we do to invent a new product area or to improve an existing one.
Well, I think there must be a lot of people pitching ideas to work on. What are the criteria that you use to decide which ones are going to get a green light?
We always think about our users and say, what is it that our users want? And if we can keep them happy, then our business will be successful.
Now, some companies say, well, it's all about the money. We want short-term profit. We want the quarterly report. Other companies say, we want products that are going to succeed over a long term. We're trying to change the world somehow, and the money will follow if we succeed. So where does Google stand in that continuum?
I guess more towards the latter. I think we have a very successful business, and we understand how that works, and we want to keep that going. But in order to keep it going, we got to keep our users happy, and they're happy right now. But the future is always a moving target, and so we've got to be aiming ahead to come up with new things.
Now, does Google stick to its core strengths? Because traditionally it's been a software company, and now it looks like it's getting a little bit into hardware. Is that a natural transition? Is that something it can be competitive in with people who have specialized in hardware from day one?
I think you're right that it is important to stick with your strengths, and I think we're doing it in a way that's consistent with that. And so if you look at things like the work on the cars, well, obviously there's a hardware component involved, but we got into it because of the expertise we had in software. That we'd already gone out and we have all this experience collecting the maps and dealing with data at that level. And we saw the cars as an extension of that, as a way to say, yes, it's a hardware project, but we're going to apply our type of software, our type of dealing with large amounts of data and building better software within the hardware platform.
Now, there's another project that Google has announced, which is the computerized eyeglasses, where the lenses are computer screens. What can you tell us about that?
Very experimental at this stage, so we don't have a product offering yet. We're experimenting with it. You've seen some of that in the press. The idea is to have a better way to interact. You know, we used to have these things called the PCs, the personal computers. Now they're the impersonal computers. You know, they're the big clunky thing on your desk. And the personal computer right now is the phone that you carry with you. But it's a little bit awkward to pull the phone out of your pocket and unlock the screen and figure out how to interact with it. If you had a screen right there in your glasses that was heads up, it would be easier to interact with. And we're trying to understand how that works.
Would you wear those while you were walking? I mean, would it make it hard to see in front of you?
It's not hard to see at all. And so I've got a chance to play with a prototype. And it's in one eye, there's a little bit of screen, and it's kind of off to the side. And so it's not blocking any of your view. You can still see straight ahead fine. And then if you sort of glance up to the side, you can see a message displayed on the screen.
And how do you control it? How do you give it input to tell it what you want it to show you?
I think we're still working through that, but you know, it's a combination of gestures and voice commands and taps on the side of the device.
What else could be of interest to Google? Like, what else are you working on that maybe I haven't thought of? That we just have a couple of minutes left. So let's go out with a big bang here. And actually, I just got the signal we have 3 minutes left. I thought we had 2.
Okay.
Okay. We have more time than I thought. Go ahead.
Well, one of the projects I'm excited about has been written up a little bit lately on our deep learning, and this is a little bit of a technical term. So what deep learning means is that we learn from examples. So we have some inputs and some outputs, and you learn that mapping. But instead of learning a direct mapping from the input to the output, you learn some hidden interstate. You say, you know, here's the input, say, is a picture. Here's the output, an interpretation of the picture. It's a cat on a table. Somewhere in the middle, there has to be a representation of cat.
I just found out that I got a wrong signal before, and we are out of time.
Okay.
So we're going to have to wrap. I'd like to thank my guest, Peter Norvig, Director of Research at Google. Thanks for being here today.
Great being here.
Thank you for watching. Visit us at www.futuretalk.net. For Future Talk, I'm Marty Wasserman. See you next time.
Thank you.